So you probably have realized a lot of the people keep talking about this program called XIS in various ways. She talked about it with the ASCE talk, Dave talked about it with Florida. Heather asked me to give this presentation, and originally I was going to give one case study of one XIS implementation. But the more I thought about it, the more I thought that would kind of do you guys a disservice. Most of you only have nebulous ideas of what it is, and you kind of by definition you don't have the bird's eye view of how flexible it is and how it can be applied to completely different situations and solve a number of different problems that would seem on the surface to be completely disparate issues. So I'm going to give you a much more high-level view of how a bunch of different people and different organizations are using the same program to solve their problems. You'll probably see a lot of similarity to a lot of the talks you've gotten so far. I'm going to mention Florida, I'm going to mention ASCE, I'm going to mention PLOS. Hopefully this will work to round out those conversations as well as give you additional insight into the program itself. So what is XIS? XIS is an XML Intranet System. It's a module of Data Harmony, much like the Source Master or Maestro, which you guys are probably more familiar with. It's an object-oriented metadata management system, so the idea is that it's a centralized database of metadata. It acts as a centralized database for disparate content types, so most of us work with XML or text, but with XIS you can work with other things. You can work with PDFs, you can work with videos, you can work with a variety of different content types, and you can unify them into one database, which is really one of the huge strengths of it. It integrates seamlessly with the Source Master and Maestro, so you can use your XIS data and call out and do MAI calls to give you indexing against any number of Maestro projects. And it allows you complete control over the data you need to capture. So one of the things that is a reoccurring theme with the clients that we have is that you have legacy content systems, you have all this information, but you only really need a couple of pieces of it. But you kind of have to keep all of it by definition. XIS allows you to really say, I only really care about these things, just give me those things. And as you come up with new fields that you want or new ideas that you want to surface, you can start to take advantage of this. Any field can be tied to authority files, and this can either be a flat list or it can be a taxonomy. And that allows you to maintain data integrity at a higher level, which we all, I think, can appreciate the value of. You can also use it, I mentioned this already, but with various other data types, PDFs, URLs, etc. So it plays nicely with linked data and things other than just text files. And then everything inside of XIS can be accessed through Java API calls, which makes it really easy to surface any of the XIS information in a variety of different environments, to call into the XIS database and pull back just the fields you want, to surface it on a web page, a lot of different variety there. And it has really strong, robust Boolean search functionality. So, what is XIS? First and foremost, you need to understand it's schema-centered. Everything in XIS goes back to the schema that you define. So you say, I have records that are articles in a journal. So I care about the text, I care about the title, I care about the abstract, I care about the keywords. Or I have records that are video records. I care about where the video is located, what the keywords are. You can completely determine what you want and you put that into the schema. This makes it highly customizable and it's completely self-contained. So it will always reference the schema. If you change the schema, it will change everything inside the system. And it's expandable, so you can constantly add new fields as they come. So this is just kind of a rundown on how the schema works. You have an XML file, which is the schema, and that's your project. You can obviously have an infinite number of projects if you want to. Inside of each schema, you have doc sets. So maybe you have a doc set for people and then another doc set for organizations. Those are each going to have different fields that are of value to the individual document type. And then you have fields inside of each doc set that you define. So this says, I care about these fields only, or I care about those fields only for this particular item type. And then you have authority files that can be referenced from the entire project. So, for example, taxonomy can be applied to multiple different document types inside of this project. So who uses CIS? We have a large variety of clients from diverse fields using it. I'm going to mention these ones today. There's some more, but these are the big ones that I would like to cover today. We've got the University of Florida, we have the Metropolitan Opera, American Waterworks Association, PLOS, ASCE, and then we use it internally at Access Innovations for a number of things. So ASCE. CIS powers the civil engineering database for ASCE. This is a centralized repository for all of the ASCE data, including the data that's not already surfaced in ASCE Library. So ASCE Library, obviously ASCE would like you to go there to purchase their content and find their content, but they also have additional content that they want to surface to show you additional information, to allow you to access additional things and increase the value of their information. They needed a way to surface this information. They had it internally, but they needed an easy-to-access website to do it. So we took all of the ASCE library data and all the other data and put it into one CIS project and then surfaced it in one spot. Importantly, because ASCE wants you to go to ASCE library, in instances where the document exists in ASCE library, we push it forward. We push the end users to ASCE library where they can purchase it. And in situations where it's not in ASCE library, we surface it on our own. So it really is one of those situations where you can determine exactly what you want to do with the information and then do it. ASCE has probably the largest number of fields for one single doc type. They have 129 fields for their main records doc set. So that means that they have everything from multiple keywords tied to multiple thesauri, to DOI information, to textual information, to journal codes. They've got all of it in one place, and they can add as many fields as they want, so I'm sure that there'll be more fields added soon. And they also have 263,000 records in their database right now, and it's ever growing. So it's a pretty large database with each field, or each record having a lot of information inside of it. Here on the left, you can see the CIS Java client, which should look familiar from my talk yesterday. This search functionality, you can see all the fields there, is surfaced on their website right here on the right. So the website is using Java API calls to utilize the same functionality, and they are able to determine exactly what they want to search for each one of these fields. So they can customize it and say, we want to search all the fields, or just the title field, or we want to have a publication year date range. I want everything from 1990 to 1995. All of that is surfaceable and customizable because it has such a robust backend inside of CIS. Standardized data allows you to do easy searching and filtering. So we're all probably familiar with filters. There's a lot of fields inside of the ASCE data that are standardized and use authority files. All of these empower things like selecting which journal you want to search inside of, or filtering content when you do have a search results. You can surface this all just by tying into the existing CIS database and make a better, easier environment for your end users to find the data that they're looking for, which is the end goal for all of us. Individual records, those that aren't pushed forward to ASCE, can display whichever fields you want. So we went to them and we said, what do you want to show them? Like, you probably don't want to show them your internal notes, but you probably want to show them things like the title or the abstract or the keywords. And here you can see the taxonomy terms we've linked out. So if you click on one of these taxonomy terms, it pushes you to a search on the taxonomy terms and surfaces that data. This allows for easy browsing between content types based on what you find inside of an individual thing. Well, again, empowering end users to find the content they want as they go, rather than assuming that they know exactly what they want when they start. Again, visualization features can be included to create additional engagement. So these visualizations tie directly into the CIS API calls. The system knows exactly what you mean when you click on water management, and they can surface that information. This can work with any kind of controlled vocabulary. It's not just keywords. Keywords are obviously one of the things that we care about a lot, but we should be looking beyond it and trying to envision what we really want with our end user experience. American Waterworks Association. AWA uses CIS to power their WaterNet portal. which stores their metadata archives. They have a variety of different things, including standards, manuals, books, videos, conference proceedings, journal articles, etc. So again, you can see the variety inside of CIS. You can really store any kind of document as long as you can define what you care about in that document and surface that information in a variety of contexts. For their data, they have a smaller database than ASCE. They have, on average, 46 fields for each document type, and they have 80,000 records. So it's a smaller database, but it's still pretty robust and pretty large. Here's their front end. Again, you can see a lot of the same things with ASCE. They use side filtering based on controlled fields. You can expand the search results. So in their case, there's additional logic where if you want to look at more information about item number 1 in your search result, you can expand it and read the abstract right there. It allows users to get the information they want quicker and with fewer clicks, which you should all be shooting for. Also, you can do things like you can put it all behind a login wall and control who can access it. AWA uses this internally, so they don't want everybody to be able to access it, whereas ASCE wants everybody to go to it. They want to surface their information as widely as possible. It really depends on your use case and what you're going for. University of Florida. So, as Dave talked about in his presentation, the University of Florida system is designed, to steal Jane's phrase from the other day, to be the one database to rule them all. So they have a bunch of disparate content in their special collections that are all different and cover a huge variety of things, everything from Florida citrus labels to the Cattleman's Journal to theses and cubic records, the carb records. All of those are obviously notably different, and you never know what the next special collection will be. So they needed a solution that they could customize on the fly to capture whatever content they needed for that particular item. They also needed a way to play nicely with their legacy database system, SOBEC. So they needed the data that we keep in CIS to be able to be pulled from SOBEC for their legacy content and also pushed to SOBEC for further content coming in for forward looks. So when they get new records, they want to be able to push it into their existing system and leverage what they've already done rather than have to start from scratch. So I'll talk about that in a second. It also allows, as she mentioned with her database, us to export CIS records into a MARC format for further ingestion at other repositories like OCLC. Once you know what fields you're mapping to, you can say this field in CIS goes to this MARC field and this one goes to that one. It's a relatively simple thing to set up an export function where you can say, okay, I want to get a MARC export of all of these records. Click a button, get the MARC records, push them to whoever wants the MARC records. Same idea with SOBEC. Do a search, push a button, get SOBEC records, push them back into the legacy content data. So once again, it's a database to control all the data from all of these different variety of sources. Theirs is a smaller database right now because we haven't fully populated it yet. It has 28 fields, but we are adding more fields as we go. Notably, these 28 fields are only the information that they care about. So SOBEC has a ton of records and a ton of fields that aren't really that important. They're important for SOBEC's data structure, but they're not as important for what we're actually looking for in surfacing the content to our end users. So this should look familiar to Dave's. Here on the left, you have a bunch of different content types, a variety of collections from the University of Florida. We are exporting those SOBEC records into CIS, so we have a map that says this field in SOBEC goes to this field in CIS, ignore that one, ignore that one, ignore that one, take this one and put it here, etc. Then we have it all inside of CIS. From CIS, we can export the records to OCLC in MARC format. We can surface the records, like with ASCE or AWA, inside of a website front end using Java API calls so that they can create a Florida portal that can help people in Florida find things about Florida. We're also creating a backup of the SOBEC records because when you're taking the SOBAC records and you're pulling out only the important information, that's great if you're surfacing it in CIS, but if you're pushing it back into SOBAC, you've just removed 80% of what SOBAC needs. So what we're doing is we're also creating a cloned database of SOBAC records when we create the CIS records. And then when we want to push changes into SOBAC, we have the map and we know exactly which field goes to which. So we can take the export, look up the original record, the original SOBAC record in our parallel database, push changes into it, things like keywords, and then push it back into their system. So here you can see CIS is really acting as the hub of the wheel, and everything can go into CIS or go out of CIS. Again, showing its flexibility as a tool to play nicely with all kinds of different environments. This is one of my favorite clients, the Metropolitan Opera. So we worked with them to update their digital archive. They had a digital archive that was based on a book indexing system, somehow. I'm a little unclear on how that ended up happening. But it was not fulfilling their needs. It had a bunch of fields that they didn't use. It had no fields for data they really cared about. So they had taken all of their data and crammed it into a system that didn't really make sense. And then surprise, surprise, they couldn't really utilize that information as effectively as they would like to. So they came to us and they wanted us to help solve this problem. So we took all of their data from their existing database and created a CIS database out of it. Again, saying what data you would actually care about, how would you actually like to subdivide this information, how do you want us to surface it. Their data is particularly interesting because it's images like this, it's reviews of operas that happened in 1890s. There's all kinds of weird stuff that happens at the Met that I didn't know about until I started talking to them. Information from 1883 includes all kinds of different things beyond just text. It's got a lot of image information. It's got a bunch of URL information pointing out to things like the Met offers an on-demand service so that you can download and watch operas. So we can push that information to people from their digital archive. They can say, I really care about this production of Faust from 1999. And then they say, oh, well, we have it as video. Do you want to see the video? So we can surface this information, which they were unable to surface before. Similarly, they also have audio recordings of a lot of their stuff. So we're able to actually surface that information to the people who care about it, the die-hard opera fans of the world. Their database is 44 fields and 28,000 records, but their field information tends to have more textual information because it's things like a full review from the New York Times or a bunch of different images and things like that. Here you can see the beta website we designed for them. You have the same search functionality. You can say, I want to search for Faust, or I want to search for this opera or that opera. You can put in date information. You can say, I only care about the performances or the presentations or the galas. You can search inside of additional fields, which you can toggle on and off, like things like funding information, basic notes about the performance. Like there was one performance where somebody died on stage that gets a lot of interesting historical things. And you can search reviews. So again, you just go to them and you say, what information do you care about? How do we structure that information and how do we surface it for your end users? On the search page itself, you can surface whatever information you want. So you can create filtering options here. They've added 2 filtering options. One is on title and one is on date. So I want the earliest performances first, please, or I want all the Fausts in one spot. You can link all the data. So there's a lot of cross-linking happening in their data. So individual performers, you can click on their name and you can get every one of their performances. You can click on an individual opera's name and get every one of the operas. There's a lot of cross-linking that's happening because they really want people to go into this archive and explore. The people who go into this archive aren't going to know what they're looking for at the beginning. They're going to want to play with the data and find out more information about it. And you can see images are integrated directly into the CIS database. The CIS database is an XML repository, but because you can specify the format of information in individual fields in the schema, you can say this field is an image. Go find the image that it's pointing to. This field is a URL. Go find the URL it's pointing to. This field is a video. Go find the video it's pointing to. So it does play really nice with things that are beyond just text. Here's an individual record page. Again, you can see the cross-linking. So up here on the top, you can see individual people who debuted in this opera. You can click on their names and look up individual things that they're in. You can see the images, and you can click on the images and get a pop out of individual images. And at the bottom here on the left, I just put it down there, they created a number of dynamic searches that they found really interesting. Things like, I want to know every opera that was done in this performance year, or I want to know all of the Fausts or anything. Again, pushing their users to explore and play with this data. Another interesting thing we did with the Metropolitan Opera is we have every 24-hour script that we run against the CIS database to create a dynamic list of performances and performers. So if you're an opera singer, it really matters to you how many operas you've been in. You're essentially competing. These are the people you're competing with, and this is what you put on your resume. So these numbers have to be accurate because they're really important to people, and the Met gets a lot of grief when they're not accurate. And it's constantly changing. So you need a way to create this report without manually going in and counting it, which is literally what they were doing before this. So we did that. Again, you can see the cross-linking. Here you have the number of performances that somebody did in order of who was the most prolific performer, when their first performance was, when their last performance was, and you can click on this information and go with that individual record. Plus, CIS powers the pre-submission filtering that Helen was talking about. It's used to help editors quickly review records and identify assorted taxonomy concepts, controversial topics, bad cell lines, endangered species, etc. Here you can see how you can have a simplified, stripped-down CIS project that utilizes a number of thesaurus calls to accomplish a completely different task. In this case, it's not about browsing, it's not about finding information, it's about speeding up the production workflow by pushing this information to end users. It can also, because you can add as many fields as you want, it can retain additional information like the SciGen analysis. Is this a machine-generated article? What's the likelihood of it being that? Author information, reference information. And as you saw in Helen's, you have all this information surfaced inside of a simple but effective web interface. Inside of Access, we have numerous CIS projects, both to use internally and to benchmark the software. So we have CISCRM, which is our internal database of organizations and people. So most of you are probably in there. It stores useful information about people. What are their names? What organizations do they work for? Did they go to the last DHUG? What did they present on? Information like that. And it cross-links between the people portion of the database and the organization portion of the database. So you can say, okay, you know, Dave is from the University of Florida. Let me look at the information from the University of Florida. Or you can be at the University of Florida information and say, oh, here's a bunch of people who work there. I want to know about Dave's information. I also created a TED Talks archive just to see if I could integrate video information into a CIS database. So this includes basic information about 2,500 or 3,000 TED Talks. It includes the abstract of the TED Talk, which has been indexed. It also includes video information, which we can then embed in a URL inside of a web page. So you can have a dynamically embedded video inside of your search results in the exact same way that images were shown on the Metadata archive. So here we can see it playing nicely with videos. Stock database, this was to test size, essentially. So I loaded in over close to 1 million records of stock data. It's really simple. It's like 5 fields. It's just the name of the stock, what the price was at the beginning of the day, what the price was at the end of the day. Useful information for financial stuff, but I wanted to put as many records into CIS as possible, and we put in about 1 million, and it works fine. A space chunk database, this is over 40,000 space objects. The idea behind it is to retain information like the altitude or the inclination, the launch date, what is the object, is it a disposed rocket booster, what data do we have about this? And the idea of this is that we can make it an open source database so that individual astronomers can catalog, record, and utilize this to increase our understanding of space junk and protect, important million-dollar satellites that are launched into space or be informed about space stuff. We also have the Hubble Historical Archive. This is a database storing historical artifacts, images, scans of records, people, pictures, things like that for the Hubble Society. So this is just a quick, broad overview. My goal here is to show you that XIS can do all of these things. It's an incredibly customizable database software that can really play nicely with a bunch of different data types. It is scalable. You can increase it essentially exponentially. You can modify it on the fly, so if you decide that you want additional information, you can add it to the schema and it's suddenly there and you can utilize it. Yeah, and I wanted to take a step back and not just focus on one aspect of it or another one, because the real value of it to me is how customizable and diverse it actually is.